Welcome to today's lesson on integration. Integration is the inverse of differentiation, so the opposite or the reverse of it, just like adding is for subtraction. So just to recap differentiating really quickly, so for example if you were given y equals x to the 4, to differentiate this you'd write your dy by dx down. Remember, differentiation is just the gradient of a curve. So you'd write your dy by dx down, you'd bring the power down in front of the letter, and then the power would decrease by 1. So we'd bring the 4 down in front of the x, and then the 4, you'd subtract 1 from it to give you 3. So your answer would be 4x cubed. So suppose that we know dy by dx is 2x. We know that the curve y equals x squared has the gradient always differentiated to make 2x. So for example, if you were given y equals x squared, to differentiate it, dy by dx, the gradient of the curve, you bring the number down in front of it, keep the letter there, and decrease the power by 1. So 2 take away 1 is 1, but we don't bother writing 1 as a power. So we know the curve y equals x squared has the gradient, or the differential of 2x. But each of the following curves also have a gradient of 2x. So for example, if we differentiated this one, so dy by dx, we know x squared would become 2x, the 2 would come down in front, 2 take away 1 is 1, we just don't write the 1. And remember, if you've got a plus 7, when you differentiate that, it disappears. So for example, this one as well, you get dy by dx is 2x, the minus 3, when you differentiate it, would disappear. And exactly the same here, when you differentiate this equation, the x squared becomes 2x, and the quarter will disappear. So loads of different curves actually have dy by dx equals 2x. So what we have as a rule is that when we see dy by dx is 2x, when we integrate it back, so when we work backwards, we have y equals x squared plus c. Now this plus c is in place for all of these, the plus quarter, the minus 3, the plus 7. So c is called a constant. So it's a value that we don't know what it originally was, but we need to write plus c because there could have been a value there originally that we don't know about. So the rule for integration. So in general, if we're given dy by dx is x to the p, then y equals xp plus 1 over p plus 1 plus c. So what this basically means is that you are going to add 1 to whatever the power is, and then you're going to divide by that value. But you need to make sure you write plus c on the end every single time, because there could have been a constant there that we don't know about. Notice this except when p is minus 1, because when p is minus 1, minus 1 plus 1 will go to 0, and the whole thing will disappear, so it won't work. The symbol used for integration is an elongated S, like this. Okay, so it's quite curvy, and it's a bit stretched out. So when we write, for example, the integral of x to dx, the dx shows us that the integration is with respect to the variable of x. So you're integrating the x that's in the question. So hopefully all of this will make a little bit more sense now when we do a load of examples. So number 1, we've got the integral of x dx. So we're going to integrate this x to get our answer. So remember what we said. You're going to take the x and you're going to add 1 to the power. Now I know we can't see a power here. That means there's a power of 1, remember. We just don't write the 1. So you want to add 1 to the power. So you have your x, add 1 to the 1 to give you 2, and you divide by this power, so over 2. So that is you integrating that x. So remember, so just as a recap, that 1 went up by 1 to give you a little squared, and then you divide by that 2. But don't forget, we said you have to write plus c on the end to show that you've got your constant there. So please don't forget the plus c. So x squared over 2 plus c is your answer. Second one then, so we've got the integral of 2x plus 1 dx. So we need to integrate both of these things, and then remember our plus c on the end. So our first one then, we have 2x. The power here is a 1, so again, add 1 to it to give you a little 2, and divide by your new power, so divide by the 2. If we have a look at the 1 then, remember what this means. When you just have a number on its own, it technically means there's an x to the 0 next to it. But remember, anything to the power of 0 equals 1, so we just don't write it. So that means when you add 1 to the power and over 1, then you need to add the letter to it. So this one is going to be plus, we'll keep the 1 there for now, 1x to the 1 over 1. Now obviously every single time we're not going to do this, so if there isn't a letter next to the value, then you're going to be putting an x there. And then don't forget your plus c. Now we can cancel this expression down, so 2 divided by 2 cancels to give you that x squared. 1 divided by 1 is just 1 anyway, so plus x, we're not going to write the power of 1 either, and don't forget that plus c. So just as a recap, if you have a number on its own, you're going to add an x to it. Example 3 then. So the integral of 4x minus 3 dx. So again, we're going to take that 4x, increase the power by 1 and divide by it. So we're going to write our 4x down, increase it by 1, so it's going to go up to a 2 and divide by that 2. If we look at the minus 3 then, so remember the minus 3 doesn't have a letter on it at the moment, so it means it's going to gain a letter, and don't forget your plus c. Again, look to see if you can cancel, so this 4 divided by 2 can cancel here, so 4 divided by 2 gives you 2x squared minus 3x plus c as your final answer. Question 4 then. So we've got the integral of x squared plus 6x dx. So again, take your x squared, you're going to increase the power by 1 and divide by it. So we've got x, 2 add 1 is 3, and divide by that 3. The next term then, we've got our plus 6x, increase the power, so because we can't see the power it's a 1, so increase it to 2 and divide by 2, and don't forget your plus c. Cancel down where you can, so this fraction can't cancel, so leave it as it is, x cubed over 3, 6 divided by 2 can cancel to give you 3x squared, and then again keep that constant on the end, so keep the plus c on the end. Question 5 then, so the integral of 2x bracket x minus 4 dx. So the first thing you want to do here is expand the bracket. So keep the integral there because you haven't integrated yet, and expand. So we've got 2x times x to give us 2x squared, and 2x times minus 4 to give us minus 8x dx. Now we can integrate. So don't write the integral out this time. So remember, increase the power by 1 and divide by it. So we're going to have 2x, increase the power to a cubed and divide by it. So divide by that 3. Onto this term then, so keep the minus there. We're going to add 8x, increase the power by 1 to give you squared over 2, and then don't forget your constant, the plus c. Cancel where you can, so 2/3 can't cancel, so leave it as it is, so 2x cubed over 3. 8 over 2 can cancel, so 8 divided by 2 is 4, to give you minus 4x squared, and plus c on the end. Example 6 then, so we've got 1 over x squared dx. So we need to think back to our indice rules that I showed you in the differentiation topic. So 1 over x squared, when we have a fraction like this, remember it means the power is a negative. So this can actually be written as x to the minus 2. Remember that minus indice means 1 over, and then the 2 is still there because that's the power, so x to the minus 2 dx. Now we can integrate it because it says a power, not in a fraction. So again, increase the power by 1 and divide by it. So increase minus 2 by 1 takes us to minus 1. Make sure you go in the right direction. All over minus 1, and then don't forget your constant of plus c. Now this can be written a little bit neater. We don't need to write it back as a fraction, but we don't really want the minus on the bottom of the fraction. So the minus comes up to the side, And then we don't need to bother writing the 1 on the bottom. So we have minus x to the minus 1 plus c. Like I said, you don't have to write it as a fraction again. You can leave it as a negative power in additional maths. So your final answer there is minus x to the minus 1 plus c. Last two examples, then you can see they get much bigger and much longer to work with. Just work out each term at a time. So this first one then, we can jump straight into integrating as all our terms are nice. So remember, increase the power by 1 and divide by it. So we've got 3x increase to 4 and divide by the 4. Next term, so you're going to have plus 2x increase the power by 1 to give us squared over 2. And remember what we said, if it's a number on its own, you need that x added to it. So this is going to be minus 5x. And don't forget your plus c. Cancel down where you can. So this first fraction is going to stay exactly the same. So 3x to the 4 over 4 plus 2 divided by 2 cancels to 1, which we don't need to write. So plus x squared minus 5x plus c. And the final example then, so we've got the integral of 12x to the 5 minus 4x cubed minus 1 over x cubed plus 2 dx. So notice this here is stopping us at the moment. So remember, this can be written as an x to the minus 3. Okay, so no fraction, we can't do it with a fraction. Remember, if it's a fraction, it's a negative indice. So you just put a minus in front of that power. So we're going to have minus x to the minus 3. So when we integrate all this then, so 12x increase the power to 6 over the 6. The next one then, so we've got minus 4x increase the power by 1 to 4 over 4. Remember, we're looking at this x to the minus 3, so write the minus down, so the x goes down, increase the power to minus 2 over minus 2, and then number on its own, put a letter next to it, so plus 2x, and don't forget your constant of plus c. So we want to cancel down where we can now, last part, so 12 divided by 6 gives us 2x to the 6. 4 divided by 4 gives us 1, so that just cancels down to x to the 4. Be careful on this one here now. So this minus and a minus here, so if I circle it, this minus and a minus can make a plus. So minus and minus makes a plus, and then keep everything else the same. So x to the minus 2 over 2, and then plus 2x plus c.